the sine rule. So I'm just going to show you where the sine rule comes from. Now, if we look at this triangle that we had before, you can see I've dropped a perpendicular down from the top to the bottom. So this length is h. Now, what I'm going to do is obviously when I've dropped that down, I've created two right angle triangles. If you look at the right hand side one, we've got angle B here, and we've got h opposite to that, and we've got the hypotenuse of that triangle being A. So the connection between these three things actually is sine. And if you look at it, sine of B is opposite, which is h, divided by hypotenuse, which is A. So we end up with this. Now if I rearrange that and take the A to the side, you can see that h is equal to A sine B. If I do the same thing with the left hand side right angle triangle, this angle is A, the opposite is again h, but this time the hypotenuse is B, so I end up with this. Now if I take the B to the side, I end up with this again. So I've got two expressions with h, and so these two things must be equal to each other. So A sine B must be the same as B sine A. Now if I rearrange it, it'll look like this. Okay. Now if I'd have done the height, or turned the triangle around and done the height from a different side, I would see that actually it's also equal to this. So what it's basically saying is that the sine of any angle divided by its opposite length will be the same for all of the three angles in a triangle. So we can use this rule. This is the one you use if you're trying to find angles. And if you turn it upside down, you'll get the form that you need for finding lengths. Okay, let's do some examples. Now, the first thing is to know when you can use it. Now, the sine rule is used to solve questions where one angle and its opposite length are known. So you have to look in the question. If you can see an angle which you know and an opposite length that you also know, then you can always use sine rule. So let's have a look at this question. Is this condition satisfied in this question? Yes, it is, because we have an 85 angle which we know, and the opposite length to that is 4. So we know an angle and an opposite length, so it's sine rule. Okay. So we're trying to find this x. Now you can see that these are all nicely paired up. So we're finding x. So from the rule it says that x over sine of the opposite angle is the same for any side. So it's the same as 4 divided by sine 85. I can take the sine 65 to the other side. And then I'm going to use a calculator to work that out. So 3.64 meters. Okay, now let's look at this next question, because it's slightly different, but it's the same principle. Now we need to check whether we can use a sine rule. Have we got one angle, which we know, and an opposite length, which we know? Well, yes, because we know this one, and we know the opposite length to that, which is 12. So we can use the sine rule. Now, we're trying to find this length x. Now, the problem we have in this question is that, okay, we want to use the x and we know we need to use the opposite angle, but unfortunately, we don't know it. But you can see we've got this angle is 37. So if you know two angles in a triangle, we can automatically work out what the third one is. So we do actually know this angle here. So let's work that out. So to work out that angle, obviously we need to do 180 minus those two added together, because all the angles in a triangle add up to 180, obviously. So that's 41. Okay, so this angle is 41 actually. So let's do the maths now. So using the sine rule, x over sine 41 is equal to 12 over sine 102. I can take the sine 41 up to the top of the other side. And then use the calculator to work it out. So 8.05 centimeters. Okay, let's look at this next question. So what we want to ask ourselves is, can we use the sine rule? Do we know an angle and an opposite length? Yes, we do, because we know these ones. So that's fine. And it's nicely set up for us because we have the pairs, opposite each other, with one thing missing. So it's definitely sine rule. But this time we're finding an angle. So we have the sines on the top. So sine of the angle we're looking for, divided by its opposite length. And then the other pair, sine 58. So now I can take the 6 to the other side. Okay, now because this time I'm finding an angle, we're going to have to use shift sine. But let's just work out what this is first. So that's 0.727 if you round it. Oops. Now you can write this as 0.727, but don't use this in a calculation. It's just to show you working out. So obviously the notation is when you've got the sine of an angle and you want the angle itself, you use this inverse sine, sine to the -1. So on the calculator, we do shift sine, and we use the answer because we want to use the most accurate version. So that will give us it on the calculator. So it's 46.6. Okay, let's look at this next question. Now again, we need to first of all check whether we have the condition for using the sine rule, which is to know an angle and its opposite length. Okay, now in this question, yes, we do, because we have an 8 and we have it matched up with the 32. So this one is possible by using the sine rule. Okay, now just to show you one which wouldn't have been possible, if I drag this one over, this one I've got here, it's very similar actually because I copied some of the numbers and moved it around. But this one, does it have the condition that we need? Let's check. Now, it doesn't, does it? Because the x goes with the 14, but we don't know the x, so we can't have that. The 8 goes with this angle, which we don't know and we can't find because we only know one of the angles, so you can't work out the rest if you only know one of them. And the 80 goes with this one, which we don't know. So this would be a situation where you cannot use the sine rule, and for this one we're going to have to use the cosine rule later. But in the one I've just shown you here, this question 4, this is possible using the sine rule because we do have a side with an opposite angle both known. So let me get rid of all this. But this one is kind of slightly different, which I'll show you. So just get rid of that. Okay, so this question. Now we do have this condition, so we know we can use the sine rule. But we have a slight issue that we don't know. We're trying to find this angle x, but we don't know its opposite length. Okay, but what we do have is the 14. Yeah. So what we're going to have to do is we're going to have to, if we call this B, we're going to have to find angle B first, and then because we know that this one is 32, C is 32, we can easily work out what the x is. So we kind of do have to pair them up. So we checked it, we could use the sine rule. Yes, we can, but we have to make sure we pair them up. Okay. So what we're going to have to do is this. So we're looking for, first of all, we're looking for angle B. So if they're paired up nicely, like in question 3, just go ahead like that. But this one is slightly different, so you have to watch out for it. So sine of B over 14 is sine of 32 over 8. So take the 14 to the other side. So let's just work out what B is then straight away. Oops. So you can just do it on the calculator. Okay, so that's the right hand side, and then obviously we need to do shift sine of that answer, sine to the -1 of that answer. So it's 68.0. Oops. Okay, now that's the angle for B. Okay, 68.0. So obviously we were looking for the x, so we know that all the angles in the triangle add up to 180. So all I need to do is do 180 minus, and then those two added together, which is actually 100, isn't it? So it's just going to be, actually I didn't need to use a calculator, it's actually going to be 80, isn't it? So in this final one then, x is equal to 80. Okay, so these cases are basically the 4 cases for sine rule. Yeah, when you have it nicely paired up, which is the most common question actually, where it's nicely paired up, that's fine. But watch out for this situation. Just check that you have a pair which are both known, which we do, and then you should always be able to do it. Well, you will be able to do it, but just in this case we had to think about the angles adding up to 180. And in the third case, again, these were nicely paired up, so there's no problem. And in the fourth one, we knew we should be able to do it because we have a length and an opposite angle, so it's fine. But we had to find the other angle first before we could find the one we're looking for.